Getting a notice any second.
Got it.
I think we just got a notice. I think I should clear my throat and welcome everybody aboard. It's the weekly Monday morning, 11 to noon vlog podcast for the South Coast Longtime Astronomy and Telescope Club we call the SBAU Astro Hour. We are, and being joined by one of our members right now, the guy that edits the newsletter, Santa Barbara Astronomical Unit, Santa Barbara, California.
Hi, Chuck. Hi, guys.
I'm your host, Vice President of the club, Ron Heron, proud to hold that duty and proud to bring to our screen on Friday for our August 5th first Friday meeting, Claire Williams, got another UCLA grad student who's going to talk about early evolving redshift galaxies. In the meantime, this is episode number 75. We've done this for almost a year and a half. August the 1st, 2022 through the 7th, as we said, Friday night is our big meeting online again. Let's meet the crew. These are the Brain Trust guys. President Jerry Wilson, good morning. Married to Pat.
Oh, good morning.
Okay, Pat Forgy is his wife. She's a longtime member, supporter. He's now our temporary webmaster and doing very good as a technical wizard. The outrageously outreachable coordinator of outreach, Chuck McPartland, is married to a Pat. Pat McPartland is our merchandise manager, and Chuck is one of the best there is, but he doesn't advise on a lot of good meteor shower watching this month. And Tom Whittemore joins us down on the bottom. His wife is Maureen, former Westmont College science instructor who's missed by a lot of students, and the monthly editor of our Santa Barbara Astronomical Unit newsletter, which is sent to us by our beloved but wants to get out of the position treasurer, Colin Taylor. Started to call him Colin.
No, Colin just wants to give up any one of two of his positions of secretary and treasurer.
He's secretary too. He's taken the notes.
Yes.
And we do meet on the second Saturday and for our meeting, and we have a party, and I'll let Chuck tell us about that in a minute. Today, we're going to try to talk about holes on the moon, cubby holes, places we can hang out that are darn temperate. They're not too hot, not too cold. Wait till you get to it. Yeah, variable star of the month for August, we'll talk about. In fact, there's 3 supernovas to kick around. I'm not sure if the variable is never a supernova, is it? Something doubles as a supernova, but the Webb telescope found one. We're going to go on to Mars and meet a canyon that's much bigger than our Grand Canyon. And meteor showers are us. Don't hold your breath. I want to say hi real quickly to somebody up in Astoria, Oregon. I haven't seen since I was a child. I heard from her, and her name is Evelyn Crispian Loftman. She's got us on. I'm sure they got good seeing at night up there in Astoria, but it's hot as hell these days there. Mr. President, now that you're in charge, you're getting better and better at this every month, and that's got to stop. I'm sorry.
Don't jinx it.
You like to send us silly science cartoons, and you keep us with levity and humor, and it's almost like being at Tom Whittemore's house. Puns are us. What do you got that you can throw up on the screen between the out of control? Let's see what the first cartoon is. Oh, this is more fascinating than it is funny, but it's a Mobius strip and comes with no warranty. Please see other side for details. You can't turn it over. There is no. Well, it's nothing but a What would you say? Is there another side to a Mobius strip?
Nope.
No. It's all the same side.
Yeah.
One edge, one side.
So just take a piece of paper, if nobody's ever done that, a big long rectangle, and tape them together, but first twist it. Right. And then cut down the middle with a pair of scissors and watch what happens. I believe the president thinks you get 2 Mobius strips. You do not. Oh, here we go. 70% of the Earth is water. Virtually none of it is carbonated. So that means the Earth is, in fact, flat.
And that's not really 70%. Pardon me. That's not really 70% by volume or weight or anything. That's just by surface area.
Right.
Well, correct me if I'm wrong, but isn't Perrier carbonated, and isn't it mined out of the ground of France?
Yes.
There are really mined. I mean, it just kind of bubbles up.
There are natural springs, even one up in Tuolumne Meadows that's called the Soda Springs, where there is small amounts of carbonated water.
Which is nothing more than good old carbon dioxide, what we breathe out. in the bubbles. All right, there's an out of control snail in the horror movie, and it's coming to town, and the guy yells, "Hey, walk for your lives!" That one I want to see. Get slimed to death. And here's a new type of zebra, next generation will have splattered across their hides, not stripes, but all I could come up with for that thing on the right side of zebra is a code of some sort. What is that? Does any of you know?
QR code.
What's it called?
QR.
QR, the letters Q and R. What does that stand for? Do you know?
Well, I don't know. Quick read.
As opposed to barcodes, which are the lines, right? On
product. Yeah.
So the lines are the earlier technology. The two-dimensional code is the latest thing. So this is an upgraded zebra.
So if you hold your cell phone up to that zebra, it suddenly appears in your living room or something. Well, now that we've got to the silliness at Mobius, I love. For our August newsletter, I got to tell you right now, it cracked me up a little bit on August 12th, and this also went out in Chuck's AU schedule of outreach. Says the Perseid meteor shower, peak of it will be ruined by moonlight. So let's be honest and transparent. And there's another one too. We'll talk about that too later on. Can we step gently? Let me quickly, you didn't want to say anything about the Korean launch. Did any of the rest of you get contacted, as I did, by Kennedy Space Senator?
I haven't had a chance to read it, so we need to have everybody see it before we talk about it.
How'd they get my address? They said
there's a lot of on the internet. There's a lot of bad astronomy. There's a lot of science fiction that's passing for astronomy. So something that pops up needs to be vetted among us before we talk about it. And I'm not saying the announcement of a launch for South Korea at Florida is bogus, but we all need to see it first.
Doesn't sound like they're trying to make any money. Anyway, what do we got here? The moon, it's in crescent. See, I write it starting with their third or fourth talking point. Heading into first quarter, it means it flipped over and it's now waxing moon, filling up. It's in Virgo Wednesday evening near the star Porrima, Gamma Virginis, Gamma Virginis, and is a binary pair, 3 degrees apart. You focus on the moon's strange terrain within the sky, the lower left. You didn't want to cruise the moon?
I'm looking here.
Okay. Do you have
it takes me a moment to get organized here.
I love the pictures you send, but I don't have a lot of chance to see them until we actually go to Monday morning podcast. There it is.
Okay. Yeah.
That's part of a crescent?
Well, you see the full moon down there with a square around it. And I don't think this is a little ahead of where the moon is now. The moon is a slight crescent. It's heading later this week toward first quarter. So we're going to be passing through this region. You want to look at this at low sun, like this picture, which is taken, because you can see all these wrinkles and features that you don't see when the sun is higher there, such as the crack in the moon's surface there. The little craters on the sea, on the dark area, they're obviously more recent than the lava flow was. Whatever hit the moon to break through the crust and liquefy things, these things happened after that. You can see the crater Julius Caesar over here, which is an older crater, and it filled up with lava, is it lava or magma on the surface? I guess it's lava. And then, but you see one rim is down from the other, and so it's only a partial crater left because it's this was a tilted crater, and the liquid flow of this lava in there filled up and obscured one side, but the high end in the mountains is still spottable as a crater. There's another rill up here, and I thought there was another one. I don't see it here, but you can see all these wrinkles, which are largely compression ridges. That is, as the thing cools, it would expand. And so, but that doesn't make sense. Rock shrinks when it when it cools. So don't listen to me on that. But these things occur in ice when the ice is compressed on the layers of ice on the Earth, and you get these ridges where the thing is compressed and it finally gives, and you get a little running rise like that. So these look like compression ridges to me.
I think what might have happened here is that's a subsidence area, and that's why
yeah.
Julius Caesar area is tilted.
Yeah.
Et tu, Brute.
Mm-hmm.
Are we on
So
the
this
edge? Are
this
we
is
on
a
the
nice.
Uh-huh.
Go ahead.
I was just going to ask, you mentioned the Sea of Tranquility. Are we on the edge of Tranquility Base here?
Yes.
The Eagle
Yes.
has landed. Okay.
In fact, the Apollo 11 landing site is right down there near the E for the little compass where it says north and east in the lower right corner.
Oh,
Right down there. Can you see my cursor?
Yeah.
Yeah.
there's absolutely no way to see the landers. There's not even the Webb will be able
The
to see
Lunar
the landers.
Reconnaissance Orbiter has taken pictures of the flag and of their footprints.
Yeah. And of the on the other sites, they've taken pictures of the tire marks from the rover.
And apparently they've even found the golf ball at one of the golf balls at Alan Shepard.
I hadn't heard that.
Yeah.
No, they can't see that small. Give me a break. Maybe it kicked up some dust, made a big sand pit or something.
If they found it, I would be curious to know exactly how far it went.
Yeah.
500
I think
yards
he had a
high.
5-iron, right?
Yeah,
Fascinating.
close to orbital.
Yeah.
So is that bare area in the middle right? Is that a mare?
Yes.
This area here?
Yeah, that's the Sea of Tranquility. That's a mare.
Oh, that
Right
is
here.
where
Yeah, there's
Rago and
The Maria goes bigger than, it's much bigger than this area, but you can see the left edge of it.
Yeah.
be darned.
And the bottom part of the Sea of Serenity at the very top.
But now this is it's a big wide crescent. If that block on the moon at the lower left.
Well, this is for Wednesday. This is for Wednesday when it's almost at first quarter.
Oh, I
Right.
see. Okay. Wednesday. I didn't.
But
Get
this is, it's too small a crescent right now to see this with your scope.
Ah,
Close.
well, right now it's when you see mountain ridges that you normally wouldn't see, or shadows.
You see the shadows, and that makes them stand out, so they're easier to see.
Kill thing, kill. If you don't mind, Mr. President, can we segue from that into lava pits and incredible places, lava tubes and holes?
Uh-huh.
Because it told us there's extreme temperatures on the moon, as we all know. I didn't really know it got that hot during the day, but it does. What, 200 and, where are my notes?
Oh, yeah, having
280 degrees Fahrenheit, but minus 280 at night. That's interesting. Plus and minus. But in between these holes where we may be staying, maybe putting our future lunar explorers, stay calm and stay constant at night at 63 degrees Fahrenheit. Is that right?
Yeah, there's extremes of temperature.
That's about 18 or so, wouldn't you think? I'm trying to learn to interpolate to Celsius. Much lower number for Celsius, isn't it?
No, it's yeah.
Am I right? I was just taking a stab in the dark. 18 degrees Celsius gives
It's in that neighborhood, yeah. Maybe a little
there's
less.
Okay. What the heck is that? A black crescent, but that's a shadow, isn't it?
This is looking down through a hole in the lunar surface, and you can see the bottom of what might be a lava tube that's illuminated by sun. So the sun rays come in, shine down obliquely into the hole, illuminate the bottom of it. This part of the hole is in shadow. So it doesn't get the continual baking all the time that's going to raise its temperature up. But this part here will be quite hot, just like the surface, but other regions over here where it's in shade will be quite cool. And assumingly, if it's got a lava tube in it, it's going to be very cool because it never gets sunshine in the lava tube.
We have those on Earth, don't we?
Yes, we do. What?
Kind of hard to imagine all that lava pouring through that, and it didn't stop and solidify there. It poured out and left perfectly rocky walls inside.
This is a lava tube in Hawaii.
Ah, there you go.
And that's what we see. It's easy to stand up in this or walk down it. That's why the light's in there. It's a tourist attraction. If you have a vivid imagination, you can see lava all of a sudden starting down the tube towards you. But, that kind of imagination, I guess, is called catastrophization or something. But that's what they're hoping to find on the moon. If we can find that, that would be, whoops.
There we go. Three separate, different ones.
That middle one looks like the same one we were looking at.
Right, but these other ones are different ones. And so these things, there are multiple ones on the moon about here. And like on Earth, they can be lava tubes. And then something will happen. On Earth, it's generally thin crust and something heavy. It just breaks through. On the moon, probably the same deal.
And then when you see several of these in a linear arrangement, it's a hint that there might be a tube between them.
Right. You can see little rills on the moon where there's a line or a depression in there, and then it's pockmarked with this, as Chuck points out, it's pockmarked with little pits.
So the reason it's 63 degrees in these hidden places that are in shadow is the ambient heat of the sun when the moon is facing the sun. Because if you were on the far side away from the sun, it would be cold as hell. It wouldn't be 63 degrees.
No, the temperature or the heat is pretty much present in the surface. And so it would stay about the same, like in caves. You can go down in a mine here in the US, on one of these places like in Silver City, Nevada. And the mine is a uniform constant temperature all year round, whether the sun is shining on the surface above or not. And it's a similar deal. The French hit on this very early by having their wine cellars in caves. So,
it doesn't have an atmosphere to conduct that heat. So the astronauts had to have suits that had water circulated constantly through them.
Right.
If they were, one side in the sun would heat up, but the other side that was in shadow would be super cold. So.
One side of their suit can approach 300 degrees, and the other side could approach minus 100 if they were allowed to just sit there.
Yeah.
Without some kind of cool or heat pipe distribution of the heat.
Jeez. What do you suppose is on the outside, the extreme outside of a spacesuit? Is it cloth or metal?
It was cloth.
It's cloth. Well, we don't have pictures of caves. Caves to me seem a little better than a hole in the ground or a hole in.
Well, this is a hole in the top of a cave.
Yeah.
It's the cave they're hoping for.
Oh, so it goes left or right, or it goes, okay.
Mm-hmm. So one real interesting thing about caves in space that I've always found that way is that a couple of asteroids are mostly metallic. And you could go to them in space once you're established a base somewhere like on Mars, and you could tunnel into the asteroid, say it's an iron one, and the iron has a lot of structural qualities that are good. You could put an airlock on it, and you'd have a livable space in there that's airtight, possibly, because you made it when you mined the metal. So there's a lot of potential for comfortable living in space, provided you don't want to go out and lay on the lawn and get baked by the sun every day or something. You have to be properly attired for each of these cases.
NASA's not going to build one of those strange orange peel openings like Kubrick had in 2001. Uh-oh.
Oh, where the spaceship landed?
Yeah, well, yeah, the big round bulbous.
They may very well do that, but it would be very foolish of them to try and bring that up to Earth atmosphere pressure. That would take so long to pump the air in and out, and if you just open too soon, you wasted all that air. Very precious up there.
Yeah, exactly. And speaking of 2001, I have the monolith on my screen.
Oops.
Big wide one. There you go.
You're back to this, yeah.
Okay, so any idea when we'll get there to use these tubes and holes in the ground?
Not a clue.
Not a clue. All right.
Budget dependent.
Yeah.
I think the first target they're having is they have is the South Pole. It seems like at least 3 or 4 different space agencies are talking about permanent bases at the South Pole because of the presence of water and year-round sunlight on the mountain peaks that they can run their solar arrays with at first. Eventually, they'll be using nuclear power.
And have you ever wondered how they're going to get the water? They're going to go out with a chisel and a hammer and actually break ice?
Possibly, if they're lucky. There's definitely going to have to be some processing. But we're going to get used to that on Earth, too. You know, here in California, we're in a drought. And people say we're running out of water, which is very misleading because we're not running out of water. As far as the eye can see west and south of here, it's water.
Yeah.
But it's going to have to be processed to get useful. So we're running out of cheap water that we just dig up and use. Space is already out of cheap water. We're definitely going to have to process it.
Well, I'm not going to ask you, gentlemen, if you drink Santa Barbara's tap water. I happen to, and I've saved a fortune in plastic bottles I haven't had to buy. I was going to ask our esteemed former Westmont teacher a question, how he felt about that, but he's not on the screen. He went to check the sourdough bread in the oven.
No, I think he's checking with his dogs. We heard a lot of barking.
Oh, that was his dogs. Okay, yeah. I didn't know where that came from.
I muted him, and the barking went away, so it was him.
Yeah, and there was somebody else there who came and actually looked into the pad.
Yeah,
that's not Tom. So,
well, it started to sound like one of my morning walks.
Uh-huh.
Shall we, without Tom, until he joins us, since he does like looking at the evening planets, is there some way we can go there, Jerry, or do you want to hit?
Well, here's more pit. Here's more moon pit.
Oh, that's the rover thing. What are they calling it?
Viper?
Pit Ranger.
Pit Ranger, that's right. And it's going to, this one, I don't see any cables, but somehow it's going to rappel down into the cave and therefore not be able to run on solar arrays. So it must be going to put something else down there, maybe on a tether or something. But I think they're going to have one to explore cave that's nuclear powered.
We actually had somebody give us a talk years ago at the club on proposed designs for going down into these craters and pits with the steep walls. And it was kind of 2 objects tethered together, and they could either clamp down on things in the soil or they could jump. And so you would anchor one and jump the other one and then repeat, you know, with the one that just jumped would anchor itself.
Well,
so
pretty
they
risky.
Flip-flop their way around.
But from my rock climbing days, if I look around there, I don't see anything that I would have my life depend on by anchoring to it. And if you start down there, you might get a scree slide started on yourself and bury yourself. So that's a very risky maneuver.
Well, maybe it runs on a couple of Elon Musk Tesla batteries. You never know.
They're too heavy.
Got a camera on it, of course, right?
That could be the flat thing here is a Tesla wall.
Yeah.
But it won't last forever. He'd have to find his way back to the hole during noon and recharge.
The Pit Ranger.
Yep. There's 2 things that have been proposed. The Pit Ranger and I forget, the Deep Diver, I think it is. Or the Lunar Diver or something, Pit Diver, something like that.
Then the astronauts someday would have to be rappelling too if they decided to use that hole. Or get a ladder or something. Fascinating stuff. So Kubrick was wrong. There wasn't an outbreak of COVID on the moon. Okay, what are we looking at now?
This is a picture of a Perseid meteor taken in a previous year on a dark night. We're ramping up to the Perseid meteor shower, which will peak about the same time we get a full moon. So it's not going to look like this in the sky.
But don't they all come from a radiant, a part that is it the radiant the same place the moon's going to be?
No.
Okay, so might we be able to see them if it's
you'll see the brighter ones, but it's really going to wash it out. So you're not going to be getting the 60 per hour rate.
Okay. Does it peak on the 12th, right?
11th, 12th, 13th in there during the nights after midnight.
A couple weeks from now. And what about the Southern Delta Aquariids? You mentioned that you're talking.
Yeah, that's ramping up too. And it's going to suffer the same fate.
Yeah. We just had the Alpha Capricornids over the weekend, and 2 other showers coinciding. Part of it was the Perseids ramping up, but it was only 20 per hour or something like that. And Alpha Capricornids are far south, pretty far south.
But I may be going over territory you've covered before. They name these showers after the comet that produced the debris.
The constellation.
The constellations where they come from.
Yeah.
They appear to come from.
Okay, which means the constellation becomes the radiant.
Right.
Yes.
And do any of them, they all have different constellations, or any of them share the same radiant?
No, in general, they don't.
When is the Leonid?
November.
Oh, okay. It's every November. So it would be that type side of the sun that determines we're on the other side in November, right? Well, it's 4 months away, isn't it? So not quite 4. Okay, fascinating.
It has to be nighttime for it to be other than a radar meteor shower.
Radar, yeah.
Well, I'm sure.
When I set up in the backyard and take some pictures, long exposures, I sometimes do it till 3 a.m. or later. Between midnight and 3, while the camera's working, I just lay in a chaise lounge and try and not fall asleep. And because the camera runs itself. And I would look during meteor showers for things and see quite a bit of, some showers are good, some are not so good. But one time up at CalStar, my son, Jesse, and I were in chaise lounges looking at the sky. And he said, "Oh, Dad, there goes a good one." And I said, "Where was it?" And he pointed right where I was looking. So that's the difference between eyesight of a 65-year-old man and a 20-year-old kid. So after that, I have been less enthusiastic about going to meteor showers because I know I'm missing a lot of them.
Did the ancients think they were stars falling out of the sky?
Yes, in some cases.
Yeah, I have no idea what they thought.
Well, we know a lot about the ancients.
That's what they wrote.
You know, the Catholic Church didn't come down hard on Galileo for saying those are just little particles. They're not a full star.
I don't think he said that, but yeah, nobody knew, I guess.
Well, he was under house arrest anyway. And
I think a lot of, there's a lot of flaming dragons and this and that.
Mhm.
Oh, yeah, yeah. In fact, all the kings back then made their decisions on astrology, not astronomy, as you probably know. Look at that view.
Yes, astronomy was an attempt to quantify astrology.
And yet they're two separate things, very far apart today, aren't they?
They are. One's based on fact and one's based on myth. It's a similar evolution to what happened with alchemy and chemical science.
Chemistry, right?
Chemistry, yeah. And people like Isaac Newton, who are very famous scientists, they were also very famous alchemists.
Is that right?
I understand that Newton was also a mystic.
Ooh.
So they had a lot of.
He absorbed a little too much mercury.
Right.
How long do you suppose they've been making horoscopes based on?
That goes way back to ancient China.
Yeah. Thousands and thousands of years.
I'll be dang. Okay, that's got a picture of one right in the middle, upper right.
Right.
There you
it's
go.
Going, I don't know what it probably is going this way because it comes in, it starts out bright and then it fades out. Or
although Perseus.
Yeah, go ahead.
Perseus would be off to the left.
Yeah. Yeah, you have a nice, so that means the upper atmosphere is thin, and as it gets to the lower atmosphere, it gets more friction. It's a very nice shot of the core of the galaxy Milky Way down in Sagittarius.
Well,
so anyway.
Every so often when we get one of these horrendous explosions like Tunguska, that doesn't come from meteor showers. That's just a rogue
asteroid. They could. I mean, it's space junk.
You know, the boundary lines between these different sizes of things, asteroids, meteoroids, comets, it's a continuum of things, of composition and size, but they're all chunks of debris in space.
Did any of you gentlemen happen to hear about the Chinese spacecraft that returned to Earth? And
it was a booster, yeah.
Okay, and it wouldn't break up somehow, and it landed in.
it did eventually break up. It landed in the ocean near Borneo. And people in Indonesia got some great videos and pictures of it burning up.
Oh,
Yeah.
so it became a meteor.
Yeah.
Did it sink in the ocean? They'll never get it again.
Parts of it did.
In the Indian Ocean, in the archipelago of what?
Well, it's Sulawesi Sea or somewhere in there near Borneo.
Oh God! So it almost hit land. Fantastic. Okay, what is this? A picture of?
I think I'm going against the grain here, but because it's a brief topic. But this is a star, a very hot star, a big star, and it was thrown out of a pair, and it's traveling about 100,000 miles an hour, and it's running into gas in space, and it's the light and radiation, it's solar wind that it's emitting, is bunching up the gas above in front of it and producing a very beautiful shock wave.
I bet you I can tell you the name of that star. Zeta Ophiuchi.
Yeah.
Yep.
Ta-da! How did I know that?
I think it must have been written down somewhere. Now, this is the pattern of things around here has the batten-off mask look of a JWST picture.
Oh,
Similar over here. So this may be color. What's that?
But it isn't.
Oh, no, someone left the batten-off mask on.
Yeah. It's another system with 3 supports.
Yeah.
so can I understand that the bright one in the middle is Zeta Ophiuchi, which is 440 light years away?
Did I stop sharing that?
Yeah, throw it back up again, just if you can, if it's not hard.
Yeah.
Because I'm curious as to how do you get a supernova with its companion that looks like that? Don't they ball out and concentric?
Well,
shells?
Ron, the supernova is not in this photo.
That's not what the big gas thing is?
No. The supernova would have been far off to the right. And it blew, and this star was in a rapid orbit around it probably, and then it just basically got flung free.
Okay. Somehow they know it was flung free at 100,000 miles an hour after its companion destroyed itself.
And this is a Chandra picture, X-ray.
That's right. So this is like a speedboat on a lake where there's a bow wave that the boat produces at its point. This is what the star is producing in the gas of space. It's producing a bow wave due to its speed through the interstellar gas.
Uh-huh. And it was blown away by its companion star. I guess they were orbiting.
It was orbiting, as Chuck points out, very rapidly around another star. The star diffused its mass so that it was no longer orbiting a point mass anymore, and it just let go. The dynamics of that star around the blow-up star no longer had the properties of producing an orbit. Now it had an open orbit.
Well, my understanding is that some of those stars, when they blow up, become black holes, whatever's left.
Oh, yeah.
But it didn't happen that way here. And they
we don't know.
No, yeah. All we know is it got flung free.
Okay, and it's running into a big gas cloud and pushing it. It'll probably make some stars, won't you think? Wouldn't you think, in that gas?
This is one of the things that does produce condensations and knots that can result, if the gas is dense enough, it can result in a new star.
And Tim had a question. Oh, Tim is saying this looks like the part of the Veil Nebula, and it does. He also had a question, basically just to illuminate for people what's the best way to look at a meteor shower, which is, like you said, sit in a chase lounge.
So between midnight and 3 or midnight and dawn.
Yeah.
Try to stay awake, have some good cocoa and coffee. Lights out.
No telescopes, no binoculars.
Right.
Speaking of sitting in a lounge chair, what happened to Bruce Murdoch? Because he's okay now, right?
Oh yeah.
Last I saw him, he seemed good.
Okay.
He and I spoke about 2 days ago, and he was having well, I'm not going to get into his medical history on the air. So he's doing okay.
Yeah, like me, he repairs himself. So good old Zeta Ophiuchi. Now, since you've brought us into the star stuff. There's a couple other supernovas, including a remnant, the Veil Nebula.
Yeah, let's go to that one if I can find it here.
And you also used the letters APOD, which gave us no.
Astro photo of the day.
Oh, is that what that is? Okay. It's in the Cygnus loop. Is that an asterism?
No, that's this whole loop of debris from a supernova.
Oh, okay.
Okay. This is the bubble. This is the shell of a supernova that happened a long time ago. It's grown quite big now. And we see small pieces of this in amateur telescopes. Most of our scopes will put this, which is called the Bat Nebula. I never knew that. And the Witch's Broom Nebula over here. And they've taken all the stars out. So 52 Cygni is about there, but it's gone. So you can just see the gas. So we can get both of these in about a 1-inch focal length eyepiece on most of our scopes. All the rest of this debris is very deep and faint, but Fleming's triangular wisp, these are news to me. I've never seen these before. I'm not sure where the Bat Nebula came from. I've never heard that either. So this and this are the two famous parts of the nebula.
And all of that is the remnants of a star that blew up.
Yes.
Yet it's got stars in it that you say were taken out. The little white dots would have been removed.
Yes, in processing. It's a retouched photo.
Are we supposed to see a triangle in Fleming's wisp somewhere in there?
Well, the brightest part looks triangular when you're looking visually.
Oh, okay. Witch's Broom. Which direction at night? Is it normally north, northern?
Well, it's in Cygnus the Swan, so now it's, rising in the east fairly high as the sun sets.
Okay, now, if you want to switch over, apparently Webb came up with one. Is this one we didn't know about? This is our third supernova.
Oh.
It's got a big, long telephone number you wouldn't believe. Galaxy SBSS J14, et cetera, et cetera, et cetera. And it goes dim and then brightens over about, 5 days?
No, you're mixing it up with the variable star of the month. This is a chance photo, maybe, I don't know, but maybe this is a chance photo on the left of multiple wavelengths from the James Webb showing a star in an obscure galaxy. On the right is a Hubble picture of the same galaxy with the star missing. The Hubble picture, or the James Webb picture on the left, caught this star, and they looked at it over several nights and it was fading away. So, ergo, probably a supernova.
Well, the two blobs are stars or?
No, they're galaxies.
They're galaxy cores.
They're galaxies. Oh, okay. And Webb just happened to see one of the stars in one of the galaxies, the one on the left.
Yeah, that blew up.
Yeah, it sort of raised its hand, so you noticed it.
Oh, okay. I got it now. What's in the what's the little hole, a little spot on the upper left?
They're all galaxies.
They're all three
it's up here. That's another galaxy.
Even those little faint ones at the very top going across, those are galaxies in the background, most likely.
Yeah.
That's not the 5 that were posted in a photograph, is it?
No,
this is not the quintet.
Oh, okay. So the photo on the right is from Hubble?
Yeah, about 10 years earlier.
Oh, okay. It would have picked it up and had it taken a picture the same time that Webb did. It would have got that.
Most probably, yes.
Brightening star. Fascinating. Jeez.
See, that's what's so easy to find about supernova, is you either have an arrow or these cross lines that intersect at the star, so they're easy to pick out.
Or a red circle.
Oh, red circle, yeah. That's the new upgrade.
Well, do they put the little? That looks like a crosshairs of a scope on a rifle.
Yeah.
Yeah.
And that's the center of your view, right? Whatever you're looking at.
Well, no, that's the object of interest. Yeah.
Oh, so you can move that grid cross.
Oh, yeah. That's just put in afterwards.
I see. I didn't know that. Okay. Wow. So, and it's got a big line. They got to get a shorter name though, Jerry. And you.
I think there's billions of galaxies out there. I don't know that we're going to see a trend towards shorter names.
Yeah. That SDSS is for Sloan Digital Sky Survey.
Oh. Okay, and the rest of it is like pi.
The rest of it is encoding probably the right ascension and declination.
Yeah.
Jeez.
So it's in the far north.
And it didn't give how far away it is, but I'm sure it's what, millions of light years?
Yeah.
Would be. All right. Fascinating stuff.
I would guess in this case billions of light years.
Yeah.
But that's purely a guess, no knowledge.
Given what the Hubble image looks like, yeah, it's really far away.
Yeah.
You want to talk about the AAVSO variable star of the month for August?
Okay.
That would be R Aquilae, American Association of Variable Star Observers, of which we're members, aren't we?
Nope.
Individuals in our group are.
Oh, okay. MIRA, a mirror type variable star.
Myra. Yeah.
Myra. Okay. It's an old.
Well, I don't know how to pronounce it. A friend of mine and I made flashcards of stars and constellations when we were 11 years old. And we never heard any of these names, but we got into the practice of giving them our own obvious soundings, which are not so obvious now that I heard the real names.
Tim texted again that the part we were calling Fleming's Triangle, or maybe the Bat Nebula, I think, was called the Waterfall by some people.
Huh. Okay. I haven't heard that one either.
Yeah, the Bat Nebula part.
Yeah.
But this sucker is a bright red, aging like we are, very old, just visible to the naked eye when it's at its brightest, magnitude 5.5, red star, red giant like Betelgeuse.
Yeah.
Supergiant.
Now that's not the one that brightens every 5 days. That brightens like 2/3 of a year, isn't it?
And this is by, I think, 270-day period.
Yeah.
Okay.
The 5 days was the period of dimming and brightening of that supernova we were looking at.
Oh,
Yeah, and it was just dimming. The from what I remember,
right.
my cat just has its flea medicine on it, and I just petted it. Yeah.
Now you're cured. What are you looking at? What is this? Explain this.
This is the light curve of the whatever the star is. The
R Aquilae.
Yeah, okay. Gotta label these better. So here you can see down about 11th magnitude. You have no hope of seeing it with the naked eye. 6-inch reflector. This is getting close to the faintest star that it can see. And it comes up in a pretty uniform brightening up to about 5.5 magnitude. So if you're under a clear sky, probably up on the mountaintop here, you could, and you knew where to look, you could probably see this star with the naked eye. Definitely easy to see in a small telescope. So this is the variable star. These measurements are estimates, visual estimates, visual pre-validated visual estimates of the brightness. And what they do is you look at a star, you look at this star in your telescope, and you have a nearby star that is of no magnitude. And then you look at the two stars together and you say, is this brighter or dimmer? And you look at different stars till you get one that say, well, this is just about exactly the same brightness. And although color is involved in it too. And that's how you visually estimate the brightness of the star. Nowadays, with most software, for if you have a camera on your scope, you don't have to take a picture of the star. It'll tell you what the brightness of the star is compared to other stars. So and that's called photometry. So it'll let you read out, and things get more accurate. These, when you look at this over this time period, it's actually changing brightness, but you can't see the subtle difference until all of a sudden it pops in your eye to another one. So that's why you get these step-like functions.
Have you ever noticed that some stars, when you can't really look directly at them, you can only see them when you look off to the left or right? Or
Yeah,
that's your vision.
Yeah.
Yeah, the center of your retina, I guess, doesn't register it for some reason. You know it's there.
Your fovea is populated by cones, which are the color sensors, and they want bright light.
Right.
And your peripheral vision is where the rods are concentrated, and they're the ones that work well in dim light, but they don't do color. So oftentimes, if you look directly at something, it'll disappear. You can look away and it'll show up.
And that's the best way to observe what we call faint fuzzies, is to use averted vision, because it's much more sensitive to dim light, as Chuck pointed out.
Are more stars variable than not variable? Like more binary than not binary?
Stars pass through a stage of being variable. So, and that variable stage, I think, is in most, at least to some degree, is in most stars' histories. So, but at any given time, most are not variables, I think.
At least not to a large extent like this.
Right.
And the ones that are CEPHEID, Cepheid variables, they're a totally different animal, right?
Oh, that's part of it. They pass through a Cepheid stage.
Oh, okay.
Their conditions are right. This bullseye marks the variable. This is Altair, an easy naked eye star to spot, and its two companions here make a nice little threesome that stands out on its own. It's a good place to start, and then you can move around to the star patterns around here. Sit down with your star chart and a compass and measure how many field of views it takes to get this way and what the direction is, and then you can move right to it. Or you can just set your go-to computer to drive the scope to it.
Fascinating.
This, let's see, this picture is set for August 3rd at 1:22 a.m.
That's what it.
Of course, you can't see the horizon, so that doesn't really matter. It's in the sky.
Yeah.
And it's high up.
Is the summer triangle somewhere in that area?
Altair is one vertex.
Oh, that's one of it. Along with Lyra and Deneb and Cygnus.
Vega and Deneb, yes.
Vega, Deneb, and Lyra or Lyra, Lyra?
Yes.
Cygnus.
I've heard both, yeah.
Cygnus the Swan. Fascinating stuff. How are we doing on time? Got 12 minutes. We seem to have lost Tom Whittemore. Hope everything's fine with him and his dog.
I'm sure it is.
You want to do the planets, gentlemen?
Oh, I think we got some good pictures on Mars, if I can figure the right one there.
Oh, yeah, Mars is fascinating. Yeah, that's good stuff here. It's called Valles Marineris.
Yeah, and that's this.
Yeah, there. Oh my God, that would be it.
Mm-hmm.
That's the Grand Canyon of Mars, and it makes ours look like a ditch in the backyard.
Now, these are the wheel marks of the rover out here. It took a month to get this pattern. So the part that the rest of the photos look at are some right in here and some down in this end. And what they're doing is the point of this topic is we have a whole batch of new photos, much higher resolution than normal. And they're very pretty pictures, but they show a lot of the landslides and stuff. And it compares it to the Earth's Grand Canyon, of course, and these were formed by very different mechanisms. The Grand Canyon, of course, was carved by the Colorado River. Chuck?
One interesting thing about the Valles Marineris features here is that they showed signs of being carved by running water also, which was a big deal. And you can see that terrain off on the left looks like what's called chaotic terrain on the Earth, where you have ice under the ground and it suddenly melts.
Right.
Okay, so like an impact, or that's near the volcanic Tharsis Plateau. You can see some volcanoes off to the left. So something heated that water up and it gushed out and it carved some of these features in the canyon, which probably started as a crack in the crust of Mars as it cooled. And then you can see where it looks like an outflow on the far right.
Mm-hmm. Yeah, it goes down here and there's like large, shallower areas, which may be where the water pooled and formed lakes.
Well, I got to tell you, gentlemen.
So this is a shield volcano, heated up ice. The water flowed down here, stayed down here, and then probably sank back into the ground or evaporated into space.
Is it possible to see this across the United States there, that drawing, as one of the reasons we first thought when we viewed Mars that there were canals? That looks like a canal.
No.
It's a little straight.
Canals are a feature of the human eye, where the visual, in a period of visual observation, people were straining to look and see things, and some people could actually put together canals or lines of different features. In the 50s, or 60s, when what was the spacecraft that went by Mars and sent
Mariner? That's what this is named after, the Mariner spacecraft.
Oh, that's right, Mariners. Sent back, and it was covered with craters and no canals. The canal vernacular suddenly disappeared.
Well, unless you gave the numbers, I'll give the numbers. 10 times longer than our Grand Canyon, 20 times wider, 2,500 miles long, and 120 miles wide. Good Lord.
And 18,000 feet deep.
Yeah, lower gravity.
That's 4.3 miles deep. So why don't we land there? What did you say, the part on the left where the West Coast, right about where San Francisco would be? You say ice?
It's called chaotic terrain.
That's not part of Valles Marineris?
Yeah, it is.
Oh,
it's just not part of it's outside the border of the US, so you might want to detach it in your mind. But it's, yeah, it's actually the source, the likely source of water, if this has water and it had water in it.
Water would have made those straight line passages?
Well, it was probably a crack in the crust initially.
Oh, okay. And then it's wide in the middle, there's something north and south there too.
There are flow patterns from up here to down here also. We'll see that.
Tim Crawford, since we lost Whittemore, why don't you type in another comment and we'll read it.
Okay. So this shows overlays of some pictures coming up. As Chuck pointed out, this is Noctis labyrinthus, which is all this terrain here is a labyrinth of lower canyons. And this looks like an impact crater, and that's an impact crater. So pictures coming up are in this region here, the Ias chasma and the Tithonium chasma. This is another region, not the one that I just showed. This is where there's an extra suggestion of possible flow pattern down in the middle of the.
And clouds actually form down in there.
Yes, and there's mist in that one. So that's this. The first one I showed was the region up here. Now the next one is going to be the region down here, just because they're out of order. And it looks like there's mist in here, clouds forming in it. It looks like mist because there is mist. So there might be water down there.
Jeez. Wow.
Wait, let me get through the new ones. Yeah, here we are with these are color coded for height. Blue is the deepest. The dark pattern is the highest, or the tan stuff. This is a nice sand dune, which you'll see closer up. These are very clear pictures. Not that. Oh yeah, this is the one that is a heat map of that surface. There's the sand dune, or that one that I pointed out as a sand dune. It's not really a sand dune. It's some kind of projection or lumping up of things. And it looks like there has been water eroding down the sides of it. Looks like there's water that has come out here and struggled down, maybe a late stage of things. Very nice pictures. They take a lot of study to look at these things. Oops.
Well, now
this shows the two regions together. Over here, just out of the picture is the labyrinth. And in here is the central region we were just seeing. And the sand dune we looked at, I believe, is this feature right here. This is, I tried to find this one. It's not so easy, but there's a chaotic terrain here. And it could be, well, that's going to take some more work. Could be up here, but I don't know.
Well,
it's fun to pour over these things.
Can you handle a question, Mr. President?
Oh, yeah.
All right. We know why we're not going to land there. We'd probably lose the spacecraft, the lander, but I'm curious about the gravity. It's about a third of Earth's, right? We weigh about a third less?
39%.
Okay, so 40, okay. Does that mean I'm thinking it would mean you could fall a little further without dying on Mars than you would here. Might you be able to survive a fall into a chasm like that, or would you still die?
I think the biggest issue with falling and dying would be breaking through your faceplate, not the impact of hitting.
That's true, you're right.
Yeah, and 18,000 feet at almost any acceleration might be bad news.
Yeah, it just takes longer to get to the terminal speed or the deadly speed. There's a very nice little clip in a video called Explorers, I think, or Wanderers, narrated by Carl Sagan. And in one of those, it shows people in spacesuits. These are all animations, but very good ones, CGI. It shows people cliff diving off of Triton, the Uranus' biggest moon. And they leap very slowly off the cliff, and they glide very slowly down. So it's projecting future sporting events for diehards. Another one shows people with artificial wings that they're flapping away through the atmosphere of Titan, Saturn's biggest moon, because the atmosphere is so thick.
Is it?
They end with maybe not today, but someday.
Yeah.
But I've read science fiction stories, which I think are based on fact, that if we did have a colony on Mars, people that are born there and raised there on 40% of our gravity here, they can't really come to Earth and stay long, or their bones will break.
There's a worry about that. People born on Mars would have a spindlier frame and a less developed musculature, because our musculature and bone density is determined by us fighting gravity all our life.
Yeah, and there's no way to fake something like that on spacecraft that are in zero gravity. They can strap themselves to a treadmill and approximate force. And
they can do that, but in like 2001, the movie.
Yeah, the running.
But Elon Musk's Starship to Mars has an idea of hooking two starships out on the end of the beams and then them rotating about a common axis. So you get essentially during the 7-month period of travel to Mars, you get essentially Earth 1 gravity, 1G. Yeah. So they'll be in good shape when they get there.
Got to be real careful when you decouple them.
Where'd they go?
Yeah.
That's probably how that fast star got decoupled too.
Yeah. Well, I heard that the rotating, the big round wheel that was shown in 2001 was going too fast. The wheel in space that Dr. Floyd landed on that wasn't completed yet, that you'd have been 1,000 pounds pressed against the inside.
That's okay. It was a nice visual effect. I'll forgive them the inaccuracy.
Yeah.
But there is a company that is formed to build a hotel just like that in low Earth orbit around the Earth and launch it in, I think, 2027.
Is that Bigelow?
What's that?
Is that Bigelow?
I think so.
With the inflatable modules, yeah.
Yeah.
Well, we got the telephone call thing taken care of. We're all carrying our own now.
Yeah.
Kubrick never had that going for him. we're out of time and we lost some of our people. We'll find out maybe next week. In the meantime, we're going to have a Friday night get together online that people can watch on YouTube, just like this, Jerry or Chuck.
Yeah, Friday.
Yep, Friday, yeah.
7:30.
All Zoom.
All right. And Tom Totten, our regular webmaster, will be sending out the connection link, if you will, to Claire Williams, our UC grad student who's going to be a doctor of astronomy someday. And she's a friend of Briley Lynn Lewis, incidentally. That's how I got her. Worked it out. And just good luck watching meteors on the night of the 12th, right? And then the second Saturday, we'll meet outside Palmer Observatory up at the Museum of Natural History, have our board meeting, followed by another great star party. Gentlemen,
on the 13th. And tomorrow night is the Telescope Tuesday at Camino Real Marketplace. And Saturday's Cachuma Lake.
Is there any way we can bring tacos in on that too? Telescope Taco Tuesday?
Well, there's Los Arroyos right next to where we set up.
Yeah. Oh, you ever had a Choco taco? They stopped making them.
I think they stopped making them for some reason I don't understand.
Yeah, I think the Eskimo moon pie. I used to buy those, and they're gone. Gentlemen, thank you. Jerry, Chuck, we'll see you next Friday night. We'll see you. Hopefully, we'll see everybody.